Hi, everyone. Thanks for joining today. So in this session, I'm going to be talking about reducing risk and strengthening cyber assurance. And to do that, I'm going to be talking in particular about how you can leverage your attack surface insights and use some of the advances in AI, such as augmented security testing, as well as talk a little bit about some of the other different security test frameworks and some of the pros and cons of each. So just to introduce myself, I'm James Duggan. I'm one of the solution architects at Synack. So I've been here for a few years now, but prior to that, I used to work across government security and defense for a number of years. And I see firsthand some of the challenges with traditional testing, where typically we were testing once per year. We were struggling to arrange for the teams to come on and do that testing. And then when we'd make significant changes to those applications, we'd either have to delay the releases or accept some of that risk that we were going to incur. So one of the things I want to talk about here in this session today is how you can really leverage some different approaches to make sure that some of the drawbacks with traditional testing don't impact your release cycles or your security risk. Okay, so what I'm going to talk about is firstly the shrinking window of opportunity. So the attackers are advancing, so do we need to as well. Some of the challenges with traditional testing and comparing that to some of the different types of approaches, that real need to kind of shift from that kind of yearly box ticking compliance cycle through to much more of a continuous resilience approach. The visibility gap. How do you know what assets you've got out there, particularly when you've got a large attack surface and it's been running for a while? How can you identify those strategic insights to really maximize your improvements on your security posture and identify that root cause? And then to wrap it up, an integrated approach, some of the facets which I think you need to be adopting in your security testing approach to make sure that you're ticking each of those elements. And then for the next session, I'm going to be running through a live platform demo where I'm going to be talking through some various use cases to bring some of that to life. Okay, let's get started. Okay, so the shrinking window of opportunity. So I guess the question which we're going to ask ourselves is how can defenders, how can you really keep pace when the attackers are continuing to evolve, when they're leveraging tools like Agentic AI to be able to shift from, let's say in 2018, new CVE being exploited in typically weeks to now just 15 minutes that CVE being exploited. And some of these sort of changing tools is really lowering that barrier of entry. So with the likes of generative AI, firstly, as most of you will already know, that information is just on hand. You can ask it pretty much anything. But also, if you're using it for the likes of vibe coding, you could potentially be using it to download like the latest NIS CVEs, the exploit packs, building a framework to deploy those vulnerabilities. And what used to be a really, really specialist role in order to run these attacks, and there were not that many people that would be technically capable to do it, with that barrier of entry being lowered, the numbers of people are going to increase that can do that. But additionally, AI plus some of the other tooling is really enabling attacks to operate at a far greater scale than what they could previously. So give you an example, even just like automated reconnaissance, being able to use various tools, including AI plus others, to scan the entire IPv4 space continuously. And the implication of that, once a year, or traditional testing using human-based teams just cannot compete with automated attack swarms and automated tools and just the general, that changing threat. So last year, to give you an example, the React to Shell CVE. So that was a critical CVE with the React framework within web applications. And one security vendor that we're aware of saw nearly a 3,000% increase in attack activity in just 24 hours of the POC becoming public for that CVE. And this is something that's relying on sort of manual processes, manual testing that just cannot compete anymore. So a different approach is needed. We've got to respond faster and use some of the latest advances as well with that. But firstly, just kind of set the scene a little bit about some of the different approaches. So automated scanners and tools. So it might be SaaS tools, it might be dynamic application security test tools, but automated scanners, which are absolutely brilliant at being able to run at an absolute massive volume, be able to run continuously, and be able to run really fast and get you that information quickly. So typically these operate on a signature based. So is that particular vulnerable component used, such as say the React CVE, are using another vulnerable web app, or very much kind of a signature based scanning. Doesn't always mean that you are exploitable, because there could be another component in there, but there's potentially a likelihood of. One of the big drawbacks with that, though, with running across a huge number of assets and that signature-based scanning, is that it can lead to a really high number of false positives. So a huge amount of information, scan across your entire stack surface, but potentially a number of those vulnerabilities may not actually be exploitable or false positives. And also, those scanners are very kind of, I suppose, linear in their approach. Have you got a particular signature within that application or infrastructure that corresponds to a vulnerability? So let's compare that to traditional consulting. So traditional consulting, whereby typically you've got a scope, whether that be applications, infrastructure, mobile, whatever that happens to be that you've defined. You know when you want that to be tested in line with typically a release cycle. You then engaged with typically a penetration testing or red teaming company, and you'll put that out to tender. Then you might have to wait several months while you get the right people once you've gone through the commercial process of acquiring them. But absolutely brilliant, where you really sort of need that sort of methodology driven creativity that humans bring, and that sort of in-depth look across those applications, be able to move from one sequence to another, trying something, looking at that. If something doesn't work, trying something else. If it uses particular technology, focus your sort of attack set based on that. So going through essentially that sort of reconnaissance piece, then deploying a number of different attack tools you're going to apply, and then a report write-up based on what you can find. And typically those report write-ups are PDF documents containing a list of vulnerabilities. Can be challenging when you've got a number of like software teams and people who need access to specific information within what they're looking at. So really be able to kind of narrow it down and be able to have it in a more kind of actionable way can be challenging there, but good at having a sort of in-depth look at a application or infrastructure or system that needs assessing. And then let's compare that to kind of your kind of crowdsourced security testing. So one option of that is using a bug bounty, whereby you pay people for the exploitable vulnerabilities that they find. So it's great for where you need results quickly, typically for impactful vulnerabilities, because you'll pay more for the more critical vulnerabilities. But it can cause people to kind of focus in just on certain areas, and you don't necessarily get that guaranteed coverage across the application or capability that's being assessed. But it is equally really, really good for bringing those sort of set of diverse perspectives, where you need more sort of tools, techniques, procedures sort of being deployed across those applications or infrastructure in a way that kind of really emulates the threat. But some of the drawbacks can be, one, as I mentioned, it doesn't necessarily mean you get that guaranteed coverage, because people are kind of focused on gives me my maximum return on investment for where I'm basing my time. But also it can be unregulated with unknown researchers, and that leads to certain challenges as well. And then kind of going beyond kind of automated scanners, and with the emergence of agentic AI over the last few years, being able to use that to kind of go beyond a scanner, but sit kind of between that and kind of traditional testing, because you can now use some of the elements from agentic AI to really help understand what an application or infrastructure does. So essentially go through that reconnaissance stage. Don't just go through a linear approach. Go through a number of steps of reasoning. So, okay, it uses this set of technology. Okay, well, I'm going to go and find these set of attacks, which I'm then going to deploy and see if it's vulnerable to, and then be able to have a speedy write-up of those results in a way which are human readable and actionable. And that's something which really enables us to go beyond what a scanner does and sit somewhere between that and what human-based testing can do. Human's still absolutely critical, sort of bring that level of sort of creativity and depth where you get that level of intuition that humans bring. But certainly, agentic AI is enabling us to give us that sort of step change and operate at a much faster speed with a lower number of false positives than we would have had previously with scanners alone. But just want to kind of build on that kind of traditional consulting piece and kind of some of the challenges, particularly with running kind of once a year testing, whether that be kind of red teaming or point in time penetration testing. Okay, so on the y-axis here represents the number of exploitable vulnerabilities. The x-axis across the bottom represents time. So what this first chart here is showing, the one in red, is doing a one-off test, finding a number of exploitable vulnerabilities, and then you're then going to remediate them, which brings that number of vulnerabilities down. And one point to add here that's really, really critical is that when you remediate those vulnerabilities, that you do retest and make sure that your remediation has been successful. It's quite often that teams remediate vulnerabilities, but the first attempt or remediation wasn't successful. So it's really important that you retest as soon as you fix it. Don't wait until that next potentially 12-month cycle away to retest, because it's quite common that we talk to customers, I retested before, I've already patched, but I haven't retested. And then that vulnerability is still lying there in your system, potentially waiting for a threat actor to take advantage of. And then what this increase is showing that over time, as you're making changes to your application, so most people are following a regular release cycle as you're adding in a number of capabilities in line with your software delivery lifecycle. So you're making changes, potentially they're vulnerable, and potentially there's exploitable vulnerabilities in that system now, which a threat actor could take advantage of. But initially, new CVEs get found all the time. So there could be new CVEs and POCs available that a threat actor could be now taking advantage of. And again, then that number of exploitable vulnerabilities in your system could be lying there for a significant amount of time, giving a large threat exposure time that a threat actor could take advantage of. So ideally, you really need to be trying to drive that number down to zero as soon as possible and keep it there. And the keep it there is the key bit. Okay, so let's compare that to a different approach. So the line in blue. So this represents continuous testing, whether that's with humans, a tool, AI, combination of the both, combination of either of these. So what this is showing is finding exploitable vulnerabilities, fixing them, and remember, retest as you do that, but then keep retesting. So here, you've released a new capability or a new CVE has been found, and then there's an exploitable vulnerability in the system. But because you're testing frequently, as quickly as you're essentially putting that vulnerability into a system, you're finding it, you're fixing it, and you're bringing that number back to zero, and you're trying to keep it at zero as quickly as possible. And ideally, you're going to do a lot of this in pre-prod as well. But bear in mind, there's always the risks with misconfiguration as you deploy to operations. So ideally, you do need to test in both. But the key point here is continuously test and try and make sure that you fix the vulnerabilities that matter most and retest and try and keep that number as close to zero as possible. And as you're going through this, I'll talk a bit more about this in a moment, you're going to be collecting a lot of data, which gives a lot of insights. And this is going to help you work out where you focus your efforts as well. So I just wanted to kind of give a little bit of plug to kind of NIS2, or the Network and Information Security Directive 2, which came into effect for the EU last year. And there's significant fines here if organisations don't comply with this. Just to add as well that separately that the UK government is also progressing with its own cybersecurity and resilience bill, which they're also currently developing. But it's just a few bits that I wanted to call out, particularly related to security testing. And this kind of emphasises that continuous validation over point-in-time testing, and that point-in-time testing just isn't viable going forward. Being able to be accountable for your supply chain. So if you're going to integrate with a piece of equipment, understand the APIs that you're going to integrate with. Has that other piece of software or capability already been tested sufficiently? And when you do integrate it, what about the misconfiguration type issues? And ideally, those suppliers should have their own vulnerability disclosure program, or VDP, enabling anybody from the public, if they do see an issue across that piece of software or system, the means by which they can responsibly submit and tell somebody that they found an issue or vulnerability with it. And then really important that organizations know their attack surface, whether that's infrastructure, web, whatever that is, have really good visibility on what that is and what's exposed, so that they're making sure that they secure it before a threat actor takes advantage of it. So as I said before, this is moving much away from just kind of being the standard kind of box ticking process that you do on a once per year basis, through to a real focus on a meaningful shift towards resilience. And there are a number of other areas. I'm not going to talk about them in any detail here, but are things like having good processes for how you manage risk, whether that's encryption, multi-factor authentication, ways in which you report incidents, focus on business continuity, and really strong governance process for how you assess and undergo your sort of cybersecurity, including the training. Okay, so visibility gap. As I mentioned at the beginning, as your attack surface is increasing, there's an increased risk across that. There's things you just don't know about. What about shadow IT? What about the development teams who, in trying to be innovative, in trying to respond fast and trying to maintain a competitive edge, they've been experimenting with things and trying to do stuff, but they've essentially left something exposed, again, to a threat actor that they could potentially take advantage of. Really frequently, and this is one that we see a lot in the field, that when we onboard a new customer, we almost certainly find that they've got a large number of assets that they just didn't know that they owned. Whether that's infrastructure, whether that's subdomains, whether that's web applications, it's really important that you know what applications you've got or what assets you've got, understand the criticality of that. And that's a really important point as well. You need to know the criticality. So you need to know what level of testing or what priority you would put if there was a vulnerability in a particular area. So just to kind of talk through an example here. So the Reactor Shell CVE, so 2025-55182 vulnerability, which came out at the end of last year. So this applied to a vulnerable version of React, which was susceptible in web applications. So question which a number of our customers were looking at the time was, quickly, can you tell me which assets are prone or vulnerable to that particular CVE because they either use React? And the first question was, just tell me what web apps I got, then which ones use React, so you could really focus and target your testing efforts. And this really kind of helps kind of shift that sort of legacy sort of position of, here's a set of infrastructure or set of assets that I want you to test on a particular basis, through to I want to secure my perimeter, or I want to ensure that I want you to test and understand what's my current risk profile at a particular point, and have that current as well. So as you've got a much larger amount of attack surface, as you're doing your testing much more frequently, you're going to get much higher volumes of data, masses of data typically, and you should be recording and using that data. And there's a large amount of insights which you can capture from that to really sort of identify those sort of strategic insights to help you work out what are those parts that you should focus on most, so that if you're looking at where do I focus a certain portion of my security budget, how do I maximize that return on investment to really have a meaningful improvement in my security posture. So that's collecting up information such as what types of assets are the most vulnerable, what types of technologies are the most vulnerable, what the location of those, what teams are releasing the most vulnerable assets, and which teams can be useful, because that could highlight, do certain teams need training, or do they need more resources? Particular location. So to give an example here, we had one particular team that they were able to, through the data that they were able to pinpoint that the problem originated from a gold image, which was being utilized across multiple applications, which essentially was a systemic issue, whereas if they fixed that one image, it essentially closed off that whole set of vulnerabilities. So just having this type of information really helps you, one, being able to maximize your return on investment when you do take particular actions that you're going to take to improve your security posture, but also be able to measure, are you moving in the right direction? Are you being effective in what you're investing in? And what does good look like? So if you can benchmark yourself against industry peers, this can be great as a board level metric, be able to say, okay, this is how I perform relative to, and just to really kind of show, is that investment working? Am I doing the right things? And that can kind of shift you much kind of away from just, I found a lot of vulnerabilities, through to, I fixed a lot of vulnerabilities, I've decreased my mean time to remediate, and you can then see that sort of step change level of improvement. So just wanted to bring up a framework for cyber insurance. So the Continuous Threat and Exposure Management Framework, sort of put forward by Gartner a little while ago. And this is kind of shifting again, much more from that kind of reactive patching through to continuous and validated assurance. So puts a big emphasis on understanding what are you going to look at, understand the criticality of your assets, continuously discover, as I mentioned earlier, about use open source intelligence, really make sure that you keep track of what assets you've got. Prioritization. So understand what matters, what's the business impact of those assets. Are those particular vulnerabilities which have been found by a scanner, are they actually vulnerable in your environment? Whether you're going to do that with humans or increasingly leveraging tools such as Agentic AI in order for you to validate that at scale. And then when you do mobilize your efforts to fix what matters with the greatest business impact, ensure that you fixed it successfully, and to be doing this on a continuous basis. And that's the really key point. And I think that's the bit I've been trying to emphasize throughout this, that continuous testing frequently, at least in line with your level of release, and being able to respond to new CVEs. This is the critical piece. And being able to move away from just, we scanned a huge number of items through to, we've had that meaningful impact in our security posture. We've reduced the probability of a breach. So to put this together, what's really needed is an integrated approach. So integration over isolation. And as you've got huge amounts of data and you're getting this sort of flow of discovering assets, testing assets, producing data. So be able to really sort of streamline this and integrate with your security operations, whether that's the likes of ticketing tools like Jira or ServiceNow, be able to do this in an efficient way so that you're not being overbearing on your teams. So that, again, that they can focus their efforts in the right place, and being able to use the right type of tool or right type of testing for the right type of asset at the right time, or hybrid of both. Whether that's scanners to operate at a massive volume, human-based testing to be bringing that creativity and depth, crowd-based testing in order to really sort of have that maximum risk reduction, and agentic AI in order to sit in between. And it's not saying that you use all of these for everything, but there's some different approaches here that you should at least be considering when structuring your security program. And having data is absolutely critical. So identify those insights from that data which help you to work out what to focus on to have that biggest impact and return on investment. Shifting away from just, I found a lot of bugs, to I focused on the right area that maximized the improvement for your security. So I'm really sort of shifting to fixing so you can focus on really sort of improving your security across a number of areas, not just individually. And ultimately, it's that hybrid approach is key, and ideally without like lengthy contracts like statement of works, which might take you a long time to then go and set up the next test. Because remember, as you're building up all the potential exploitable vulnerabilities in your system, particularly when you don't know about them and you've not put any controls in place, there could be a threat actor looking at them and ready to take advantage of them. Okay, so thank you very much for listening today. I hope you found that interesting, and hopefully you'll come to the next part where I'm going to run through a number of demos and use cases, such as how you can leverage your attack surface insights, some insights you can identify from that data and the analytics, and then finally some features for a streamlined approach to help you keep pace with the threat.